Hi. So in this problem, we're going to take a look at this reaction. N2 plus 3H2 gives 2NH3. And what's given to us is that nitrogen is reacting at the rate of this. So, and what's asked of us is what rate is NH3 being formed? So what's important to realize is that nitrogen is a reactant and NH3 is a product. And what we need to understand is that reactants deplete over time while products increase over time. So therefore, the rate of nitrogen forming is going to be a negative number. So it makes sense that it's given to us, the number that's given to us is negative. So what we have to do is we have to assume that if we that the rate of the reaction can be expressed in terms of the amount of nitrogen depleting over time or the amount of ammonia increasing over time. So let's write down an expression for the rate of the reaction in terms of the nitrogen and then in terms of the ammonia. So we can write rate is equal to change of nitrogen over change in time. So that is one form of expressing the rate in terms of the nitrogen. But then this rate can also be expressed in terms of the ammonia. Now this is the negative, I'm sorry. So now this can be also expressed in terms of the ammonia. So that's going to be change of the NH3 over change of the time. Now what's important to realize is for every nitrogen, just looking at the stoichiometry of the reaction, for every nitrogen that is being consumed, 2 molecules of NH3 is being formed. Therefore, we can say that the rate of the reaction, the rate of NH3 being formed is twice that of nitrogen. So if you have to map this rate with this, then actually we have to take, since the rate of the NH3 forming is double, we have to half it to be equal to the nitrogen. So therefore, we put 1/2. And a quick and easy way to think about this is whenever you're looking at a reaction, if you have the product out here, for example, or the reactant, and you're trying to express the rate in terms of the quantity of or the molarity of the reactant or the product decreasing or increasing over time, all you do is take the change, the delta N2 or the delta NH3 over change in time, which is delta T, and just put the coefficient as a denominator. Put it 1 over the coefficient, and there you have it, okay? All right, so now once we have this expression out here, we know that this is equal to the rate. So we're just going to, essentially, we're going to take this and form an equation out of it. So we already know what this is, that's given to us. So we're going to write that as minus of negative 0.005 per molar per second is equal to 1/2 of change in the ammonia over change in the time. Okay, so and we're solving for this. So let's call that x. So let's say 1/2 x is equal to minus of minus 0.005 molar per second. If we the negatives take care of each other, so that makes it a positive. So that's 0.005 per molar per second is equal to half x. And now to solve for x, we just multiply both sides with 2. Let me just erase that so it's not confusing. So we just multiply both sides with 2. So x is equal to 0.010 per molar per second. And we know what x is. X is this. So that is the change in the concentration of NH3 over change in time. And that is the rate at which NH3 is being formed. I hope that made sense. Thank you for watching.